Hi students, today's session I am going to discuss about crystal field theory, in short form CFT, from coordination compounds chapter. Okay, after the completion of this video we will able to draw CFT for both octahedral as well as the tetrahedral complexes. Let us start our session. Metal consists of d orbitals. These 5 d orbitals are dxy, dyz, dzx, dx square minus y square and dz square. These 5 d orbitals present in the metal called as a degenerate d orbital. The reason is these 5 d orbitals having the same energy, that's why we called as a degenerate d orbitals. Electron can enter into any of the d orbitals. Okay, these 5 d orbital structures are there: dxy, dyz, dzx, dx square minus y square and dz square. Okay, here we assume that this one is the x-axis and y-axis. The lobes are between the axes here. Okay, the lobes are between the axes. For this one, dx square minus y square and dz square, the lobes are along the axis. Okay, if the lobes are between the axis, we called as T2G orbitals. T2G orbitals. According to spectroscopy, the lobes are present between the axis, that is called as T2G orbitals. The lobes are present along the axis, we called as EG orbitals. Okay, for example, COF6 3 minus and CN6 3 minus. Okay, the central metal atom consists of a d orbitals. Okay, here fluoride is there, cyanide is there. Okay, the fluoride ion or a cyanide ion, it approaches the metal to form a complexes. Okay, to form a complexes. Metal also consists of a electron. Here metal also consists of a electron. Ligand also consists of a electron. Approaches metal, there will be a repulsion between the ligands as well as a d orbital. Whenever there will be a repulsion, then these d orbitals, it lost its energy or lost its degeneracy. Okay, that is non-degenerate d orbitals. Non-degenerate d orbital. Okay, or average degenerate d orbitals also we called as. Okay, here what happened, metal also consists of a electron and a ligand also consists of a electron. These ligands approaches metal, there will be a repulsion. There will be a repulsion between the ligands as well as the d orbital. Whenever there will be a repulsion, then these d orbitals, it lost its degeneracy. Okay, once lost its energy, that is called as a non-degenerate d orbitals. Okay, does not containing a same energy. These orbitals does not containing a same energy. Okay, then non-degenerate d orbital can split into two sets. Those are EG set and T2G set. Okay, EG set lobes are present. Okay, EG set lobes are present along the axis. Okay, then T2G set lobes are present between the axis. In the case of octahedral complexes, okay, in the case of octahedral complexes, ligands approaches along the axis. Okay, sorry, ligands approaches along the axis, that is 2 EG orbital lobes energy is raised. Okay, that energy is raised. Here what happened, students, the T2G lobes having the less energy, so it will be less repulsive force. Okay, T2G lobes having the less energy, so it will be less repulsive force. This splitting is called as crystal field splitting energy. Okay, or in short form we called as a CFSE. Okay, crystal field splitting energy or a crystal field stabilization energy also we called. In short form, that is noted that delta. Okay, here for the we discuss octahedral complexes, that is called as the delta naught. O represent the octahedral complexes. Okay, T2G, here some important tricks. Okay, important tricks are there for this one. This one is the EG set. Here that is the T2G set. Okay, those orbitals are d x square minus y square and dz square. Here dxy, dyz, dzx. Okay. Next, what happens, students? Here T2G set and EG set having the some values. We easily remember here how many d orbitals are there? Total 5 d orbitals are there. Okay, that's why denominator is 5. Okay, denominator is 5. Among 2, for this one we also written. Here also denominator is 5. Total 5 d orbitals are there. That's why total 5 d orbitals are there. We written denominator is 5. Okay. Among 2 d orbitals, that T2G orbital energy is decreased. So we written minus. Okay, minus 2 by 5. Total 2 orbitals, 2 EG orbitals, T2G orbitals. Here that energy is decreased. For octahedral complexes we written delta naught. Okay, then next what happened? Here EG having the some value. Okay, EG having the some value, same thing, total 5 d orbitals are there. Among 3 orbitals, that is EG orbital energy is increased. Okay, that's why positive charge. Okay, among 3 orbitals energy is increased, so we written positive charge here, plus 3 by 5 for octahedral complexes delta naught. Okay, here we written the values for EG orbital. Okay, for EG orbital plus 3 by 5 delta naught, that is equal to plus 3 by 5 0.6 delta naught. Okay, then here T2G orbital among 2 orbitals, that energy is decreased minus 2 by 5 delta naught, that is equal to minus 0.4 delta naught. Okay, for the octahedral complexes, ligands approaches along the axis. Okay, here same thing, total 5 d orbitals are there. That is the that is called as the degenerated d orbitals of a metal atom. Okay, why degenerated? Those all d orbitals having the same energy. Okay, then metal also consists of a electron and a ligand. For this example, metal also consists of a electron, ligand also consists of a electron. There will be a repulsion will takes place, that energy is lost, or that energy will degenerate. Okay, that is the non-degenerated d orbital, means energy is not same. Okay, the next one, this one can split into, okay, this one is can split into 2 sets, EG set and T2G set. Okay, for this one dx square minus y square, for octahedral complexes lobes are present along the axis. Okay, that's why EG set and T2G set. Why EG set in the excited state, students? here what happened, that is the T2G having T2G having the values, okay, those are plus 3 by 5 and minus 2 by 5 delta naught means crystal field stabilization energy or a crystal field splitting energy, the difference between EG set and T2G set, that is called as the crystal field stabilization energy. This one is for octahedral complexes. Next one is the for tetrahedral complexes. Here the same. Okay, metal also consists of metal having the d orbitals, those are dx xy dyz dzx dx square minus y square dz square. Okay, for the structures of d orbitals, here we know that one. Okay, then next one is the for tetrahedral complexes, we represent the